In this video, we're going to continue our exploration of polynomial divisions. To divide polynomials, you can use the familiar method of long division. You can use the long division. It's the same way you might divide regular numbers. If you like to review the long division of polynomials and see how it is similar to the division of numbers, please watch the video using the link. Another way of dividing polynomials is to use the synthetic division. It's called synthetic division. This is actually a shorter form of long division. So in this video, I'll be working through an example using both long division and synthetic division side by side, so you can really see how these two techniques are connected. So the very first thing we need to do is to get everything set up. For the long division, we place the dividend under the division symbol. So the dividend is 6x to the power of 4 plus 16x cubic minus 34x squared minus 47x plus the constant value of 28. And we place this dividend under the division symbol. And the divisor, x plus 3, goes over to the left. Now let's set up the synthetic division. This method is all about efficiency. So instead of writing out the full polynomials, we're just going to draw down the coefficients of each term, including the constant value. So the first coefficient is 6. The second coefficient is 13. The next one is negative 34. And next is negative 47. And the constant value is 28. We leave the variables out for now. They will come back later at the very last step. Okay, and then we draw the symbol that looks like the backwards of the division sign. And over on the left of that, we put the opposite of the constant term from our divisor. Okay, the constant term in the divisor is positive 3, so we put negative 3 here. Alright, now we are ready to divide. For the long division, the divisor has two terms, x and 3, so we need to focus on two terms each time in the dividend. Okay, so let's focus on the first two terms. 6x to the power of 4 plus 13x cubic. So we need to find a term here that when multiplied by this x plus 3, we should get a expression or a binomial whose first term is this 6x to the power of 4. So later when we do subtraction, this term will be eliminated. Okay, you can see that the term here should be 6x cubic. Okay, so if I have 6x cubic times this x plus 3, we have 6x to the power of 4 plus 18x cubic. So we have 6x to the power of 4 plus 18x cubic. Now as we subtract these two expressions, when we do this as expected, this 6x to the power of 4 terms are eliminated. And for the x cubic term, we have 13x cubic minus 18x cubic, okay, which gives us negative 5x cubic. So we put negative 5x cubic here. Alright, switching over to the synthetic division. After setting up the coefficient and this negative 3, the initial action is to bring down the first coefficient, 6. Okay, so this value, 6, is actually the coefficient of the leading term in our answer. It's this 6. So next up, we multiply this 6 by this negative 3. Okay, we multiply 6 by the negative 3. This gives us negative 18. Then we just simply add 13 and negative 18, which gives us negative 5. And now notice that this 13, negative 18, and negative 5. These numbers correspond to these coefficients of the x cubic terms. There's a little bit of difference. In the long division, we have this positive 18, but in the synthetic division, we have negative 18. The reason is because we have a negative 3 in the synthetic division and positive 3 in the long division, right? By changing the sign from positive 3 in the long division to the negative 3 in the synthetic division, we've turned the subtraction into the addition, right? So in the long division, we subtract this 18 from 13. While in the synthetic division, we just simply add 13 and negative 18. And both yields the same result of negative 5, right? All right, now let's jump back to the long division. Our current remainder is negative 5x cubic. So now we bring down the next term from the dividend, which is negative 34x squared. Now we need to figure out the term here that when multiplied by the x plus 3 will give us a binomial whose first term is this minus 5x cubic, right? So this term should be minus 5x squared. So when negative 5x squared times x plus 3, we have negative 5x cubic minus 15x squared, right? So we have negative 5x cubic minus 15x squared. Now we subtract these two expressions. We have negative 5x cubic cancels out the negative 5x cubic, and the negative 34x squared minus negative 15x squared is negative 34x squared plus 15x squared, right? This gives us negative 19x squared. All right, let's keep going with the synthetic division. Now we repeat the same process. We take this negative 5 and multiply it by our negative 3, which gives us positive 15. When we add negative 34 and positive 15, we have negative 19. Now take a look at this column. It corresponds to the coefficients of the x squared term. Again, we have negative 15 in the long division and positive 15 in the synthetic division because of the negative 3 here. All right, let's wrap up this long division. We bring down the next term, which is negative 47x. Now we are looking for a term that when multiplied by this x will give us the term minus 19x squared. So this term should be negative 19x, right? So negative 19x times x, we have negative 19x squared, and negative 19x times 3, we have minus 57x. If we subtract these two expressions, these two terms cancels out, and negative 47x minus negative 57x, we have 10x. Now we bring down the final term, which is the constant 28. To match that 10x, we need to multiply the x by 10. So we need 10 here. So 10 times x is 10x, plus 10 times 3 is 30. Subtract them, we have 10x minus 10x is 0, and 28 minus 30 is negative 2. Okay, now let's also complete the synthetic division. And we continue our process. We multiply this negative 19 by negative 3. Multiply negative 3. We have positive 57. And negative 47 plus 57 is positive 10. And 10 times negative 3 is negative 30. And 28 plus negative 30 is negative 2. Okay, now look at this column. It corresponds to the coefficients in front of x. And for the very last column, it corresponds to this one, these constant numbers. Now let's look at the bottom row of the synthetic division. The numbers 6, negative 5, negative 19, and 10. These numbers are the key. They represent the coefficients of the quotient. See, we have 6 here, and we have 6 x cubic, and we have negative 5 here, and we have negative x squared, and we have negative 19, and the coefficient of the x is negative 19, and the constant term is 10, and the constant term in the long division is also 10. So reading off these coefficients, we can directly write down our quotient. Okay, because our original polynomial was a 4th degree polynomial. We have x to the power of 4. Then the quotient will be a 3rd degree polynomial. It's going to start from exponent of 3. So we have 6x cubic minus 5x squared minus 19x plus 10. So this is the quotient. And the negative 2 here is actually the remainder, which perfectly matches the remainder we found in this long division. Okay, so negative 2 is the remainder. So now you see the synthetic division is not something completely different magic trick. It's fundamentally the same process as long division, but we stripped away the variables and only leaves these coefficients to make the process cleaner and much faster. So while synthetic division is a super handy shortcut, it's worth keeping in mind that standard synthetic division is typically used when dividing binomials, which has a form x minus c or x plus c. As in our case, we have x plus 3. Okay, so c can be any number. If the leading coefficient of this binomial divider is not 1, so here we have a coefficient of 1, right? But if it's not 1, there are some additional steps required. We'll be covering those more complex cases of the synthetic division in our next video. We will cover something if we divide something like 2x plus 3. Okay, how do we handle this? One more important thing to remember when setting up both long division and synthetic division is that the terms in your dividend must be arranged in a descending order. Also, you can't have any missing terms. For example, if we have a x to the power of 4 term, and after that we have a x squared term, and then we have a x term, and then a constant term. In this case, we don't have the x cubic term. But when we do the division, we need to add this x cubic term with a coefficient of the 0. Okay, we need to add it here as a placeholder. Okay, we'll dive deeper into why this is so important and see some examples in another video. Okay, I hope this video has helped you understand the connection between the polynomial long division and the synthetic division. Okay, if you found this is helpful, please consider giving it a like and subscribing for more math tutorial. And of course, feel free to leave any questions you have in the comments section below.